So in previous video we are discussing lambda effect or mismatch due to mismatch in VDS1 and VDS2. So why both VDS are not same? Because uh, here circuit is different from this circuit. That is the reason there is a mismatch. Now suppose if we want VDS1 equals to VDS2, then what we have to do? If we want VDS equals to VDS2, we want lambda equals to 0, or we need to minimize lambda. So it means we should remove lambda effect. Basically, if we write ID equation, this is beta is nu and cox, w by l vgs minus vth square 1 plus lambda vds. So if we reduce lambda, if we make it 0, or reduce lambda, then we can remove this VDS or lambda effect, mismatch due to VDS and lambda effect. Now how we can do this? How we can reduce this? What we have to do? We have to increase output resistance. This is R out. We need to increase this output resistance. Now RO is given by 1 by lambda ID. So if we make it 0, then RO equals to infinity. So as we are reducing lambda, output resistance equals to RO for this current mirror increases. So it means okay, in another way we can say, for any current sink or any current source or sink, we want this output resistance equals to infinity or very high. For idle current source this is infinity, but for non-idle current source this is not infinity. We should make it very high. Now how to increase output resistance of this current mirror? One way is to reduce lambda. Now lambda directly proportional to length of our device, so it means 1 by L. Now lambda reduces if length increases and R out or RO increases. So what will happen? The slope of VDS curve basically reduces as we are increasing length. So as we are increasing length, this slope reduces and current mismatch between these two, M1 and M2, reduces. Now let's see second type of error source, which is, now suppose you have this current mirror, Now suppose when you draw layout, there is a possibility because of layout designing, some resistance R will come here. There is also possibility some resistance comes here as well, and at present we are considering only here, and because of layout we are drawing, because of this resistance is coming. Now because of this VGS, this is M1, VGS1 not equals to VGS2, this is VGS2. Because of this, I1 and I2, I1 not equals to I2. So this is the one of sources of error in our current mismatch because of source resistance. Error due to source resistance or unwanted source resistance. This is one of the reasons. So one should be careful while making layout. Okay, now third. Okay, so third one is architectural mismatch. So how this is? Now suppose you want to replicate IREF current. So this is say IREF. You also want to replicate IREF. Say this size is W by L. So ratio is W by L, and this is M1, this is M2. This size is 2W by 2L. Now here we can say I1 should equals to I2 because ratio of width upon length is same, but this will create issue because length is different, and because of this I1 not equals to I2, but you can say that ratio is same, so both current should be same. But now here again lambda effect is coming because lambda is inversely proportional to length of device. Now for this case lambda is lambda 1 because it is L, and for this lambda, say lambda 2 equals to 1 by 2L. So for this lambda is small, for this lambda is large. Because of this lambda effect, we can, if we draw ID versus VDS graph, so because of difference in lambda, there is a possibility of current mismatch. So all these type of mismatch are examples of systematic mismatch. To avoid this kind of mismatch, we should take two devices instead of we should not we should take same geometry of these two should be same. Now suppose if you want to replicate say 2 IREF current, say this is W by L, and you want 2 IREF current, so you take 2 W by L. So it will also fine, but there is also a mismatch in width. So you should take number of fingers or number of devices 2 times of M1. This is M1, this is M2. So you should take 2 devices actually, not single device like this. Otherwise there will be a mismatch. So this is IREF, this is 2 IREF here. So this is correct way. This will give mismatch. So here we have seen systematic mismatch and simple current mirror. Now we will see random mismatch and other types of current mirrors. Thank you.